any that you guys didn't understand or you guys were like, wow, about, right? Except for this one. This one's kind of really cool. So I'll get you that. I'll work it out. But the idea is exactly that. Like we said, you know, it definitely is a large cone. You take away the small cone at the top, and then it's just a matter of cleaning up the formula. But I'm not seeing it right now. I'll probably be sitting home tonight, be like, you guys ever do that? Got puzzles you gotta do or something? No? Yeah.
But then you always forget that one piece and you get so frustrated.
You ever played Halo? You can't pass that level. You're like dying all kinds of times, but you're still going at it. What? What planet are you from?
But it's like, oh, you have to do this. I'm just like,
You play Candy Crush? I don't play either no more. I got tired after like level 500. JK. Alright, so anyways, let's get to this. So let me close my email. Okay, so we already did three-dimensional objects. You should have the right prisms that we talked about. You should have spheres. You should have, what else?
cone.
What else?
Just cone. That's all.
The cones, we did cones or pyramids as well.
Yeah.
Same idea, it's always going to be 1/3 of what it would be if it was a right geometric solid. So you should have those down already. You should also have the 2D as well, which is your, you know, your square, and your rectangle, and your triangle, all that good stuff. But I want to talk about one cool thing here, which is Cavalieri's principle. And Cavalieri's principle is saying, let's say you did have a right geometric solid. In this case, this is a, what shape is this? It's a cylinder, right? So we have the cylinder, and what Cavalieri's principle is saying is, well, what if it wasn't like this? What if the image was actually slanted? That's exactly like the other one, isn't it? JK. Not bad? Close enough? Okay. You guys get the idea? Oh, that's horrible. Hold on. I could probably do it worse. Okay, so anyways, something like that. So Cavalieri's principle says, it's kind of comparing two objects. Now, when I first saw this, I'm thinking well, imagine they're the same, because they're obviously not, right? One has more girth than the other. But imagine that they are the same. My first thought was, this one probably has more volume, doesn't it? Anybody look at that and say, this got more volume than this one over here?
Yeah.
Because of the angle, right? We know that when it's longer, it's like a hypotenuse idea. Therefore, it's more in length. Well, according to Cavalieri, his idea was this. If we could take a cross-section of this bad boy right here. Now, in order for this to work, here's what needs to be true. They both need to be sitting on a plane, on the same plane, on the bottom, as well as the top. So, see if I can fake this one real quick here. Does that make sense? So so they both sit on the same plane, and on the top, they've got the same plane. If that's true, then that means they're both the same height, correct? Understand that? So the height of this bad boy would be the same as the height of this one over here. So this is the height. So they have the same height. Now, Cavalieri is saying this. If I could take a cross-section, anyone understand what a cross-section is? It's like if I was able to take a knife and just kind of slice out this little piece that exists right there, like a piece of bologna right from inside of there. Okay, that single, very slim unit, that two-dimensional unit, okay, which has no girth to it. Do you guys remember that? It would be completely flat. If I could take out that cross-section and do the same thing over here, think about this. If that's simply a two-dimensional object, would it have the same area, those two cross-sections? Well, what shape would this cross-section here be? It would be a circle. What shape would this one be? It would also be a circle. So if I took that out and I said this has radius r, this too has radius r, then that means that this circle here would have radius r, and we already established that they're the same girth, aren't they? So according to Cavalieri, then those two cross-sections would have the very same area. Does that make sense, everyone? Okay. Well, what if I did that repeatedly? and I kind of took this cross section, matched it up with this cross section, would I have a cross section every single time to match up over here?
Yes.
Yes, I would. Why?
They're the same height.
Because they're the same height. So what's really trippy about this is that according to Cavalieri, is that even though this has a slant to it, I could still find the volume of that the same way I would find the volume of that, which would be in that case the area of the base times the height. Do you need to go to the bathroom? Do you need to go to the dentist? Does that make sense though? Isn't that a trippy idea? Because like when they first told me about it and they explained it to me that way, like it would make sense. But at first I'm like, nah, that's gonna have more volume. Watch this. And then all of a sudden he's like, okay, take all the cross sections, blah 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 blah. It's kind of like doing this. Think about this. If I took two, oh, maybe I could show you that. Let's see if this will work. Oh my gosh. Let's see here. Can I share with you, Marlon? So here's the idea. So the idea is you've got, like, for example, this. So if I had a cylinder, can you guys see my stack of pennies over here? No? No? Well, too bad. JK. Wow, what if I drop that? Penny mania. Let's see here. Can you guys see that okay? A little bit better than over there. So if I stack these pennies here, I've kind of got this cylindrical shape, don't I? Okay? So if I took another stack just like it, let's see if this one works. I might have to add some or remove some. Right? If I got too many, then I'm going to need less. Oh, that's creepy, Marlon. Did you see that? Ooey, cuckooey. That's math at play. So right now, obviously, they would have the same volume, right? So what the other one's simply doing, it's taking every one of those cross sections and it's kind of just shifting it a little bit. Just kind of have that idea. See that? So it's kind of like each cross section would correspond with the cross section of the other. One cross section will correspond with the other cross section. Therefore, the volumes are still the same. I got to just find the area of the base multiplied by the. I need another camera, huh? Rip it off of there. So, you understand Cavalieri's principle? Sweet. So, if I had this bit going on, this bit, that's horrible. That's gross. You didn't even see that. You didn't see it at all. Shut up. I don't want to draw now. I don't want to draw anything. I'm embarrassed. Let's go with this one. So if I had this going on, and I said, you know what, this has a radius of 3, and the height is, I don't know, we'll go with 20. Is that cool?
Yeah.
Then I could say, to find the volume of this shape, I would find the area of the base, which would be pi, or 9 pi, correct? And then I would simply multiply that by 20. So I'd have $1.80 pi. And there it is. Units cubed. Yay, Cavalieri! Not so funny anymore, huh? What'd you say? Did you say yay, Cavalieri? Yes. Good. Yay, Cavalieri! Not a Cavalier. That's a car.
He said caviar.
Like the fish eggs.
Are you making fun of the great mathematicians? What have you done for math lately?
They've done a lot more than I have.
Okay, so everyone's cool with Cavalieri's principle?
Yeah.
All right, so moving on. What if I wanted to... This is horrible. I'm not going to be able to draw this.
Can you move that cat?
I do need to go to the bathroom, actually. Oh, I gotta go 1.
Oh, okay.
Drinking too much water. So good, though. Anybody have one of those days where you just can't have enough water?
Yeah.
And then your stomach, you're walking around, like, you can hear it go, like, not cool. Not cool. So let's see here. Volume.
Like my water sign. What? My water sign. That's a bit weird. You know when you're running and it's yeah. It's like you can hear the insect. Why was it tired?
Okay, cool. Let's take this one. So, where's my snapshot for progressive? It's a triangular prism. This is a triangular prism. Hey, I didn't say do that. Everyone see this okay? I'll make it all distorted. Just kidding. So this is a triangular prism. And I know it's a right triangular prism because if I kind of took this and rotated, I could kind of stand it up, couldn't I? And the bottom will look just like the top. Those are easy to find because here's what you need to do. You find the area of the base and you multiply it by the height. Every single one of them. When they're right geometric solids where the bottom looks just like the top, all you got to do is find the area of the base, multiply it by the height. Now, obviously, this image is not lending itself to do that right now, but I'm going to have to imagine that I could actually do this with it. See how it still has a base where that's the same as the top? So all I have to do is find the area of the base and multiply it by 18 in this case, right? So, area of the base. Well, the base is a triangle, so I'm going to have to pretend this could be my base, that could be my height, because, hey, it's a 90-degree triangle. So, 12 times 9 divided by 2. 2 goes into 12 6 times. 6 times 9 is? 54. So that's the area of the base, multiplied by the height of 18. Ah, awesome.
972.
Up, 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 up.
Isn't it cute? Cute.
Ah, you didn't even let me ask my question. Thank you. Yes, so there you go.
That was easy.
Yeah? Because it's volume. 3-dimensional. If it was 2-dimensional, then it would be squared. Length, width. In this case, it's 3D because we have length, we have height, but it also has depth, doesn't it? So 3 dimensions, that's why it's cubed. Okay, if it was just a line, it would be 1-dimensional. So we don't really put that on there. We would say, oh, like this case, that's 18 centimeters. The degree is 1. Okay? Does that make sense? That was another concept that just blew me away when I finally got it. I was like, oh, 3D, 3 dimensions, it's cute. I didn't laugh like that, but I know, I'm sure you didn't. I heard you. I wanted to get some more from here because you have to deal with all of these. Any one of these that kind of strike your fancy, guys?
Number
8.
Number 4.
4? Whoa, that's a good one. Where's my tool here? Capture to a new page. Is that what it says? So let's take a look at this one. And just so you guys know, there's the answer right there. You guys can check my work. I hope I got it right. Yay. Okay. So again, this is a right geometric solid. So what are the two things I need to do? Find the area of the base. Multiply by the height. So area of the base, multiply by the height. The height happens to be 10 yards. I'm halfway there, peeps. Yay. Now the base is going to be the tough one, isn't it? Oh my God. Any ideas? Area of a pentagon.
Isn't it a trapezoid triangle?
It could be a trapezoid and a triangle. Here's what we can do. Okay? Remember how we spent the last 2 weeks using good old trig?
Oh, yeah.
Yay, trig. We're going to kind of do this bit here. Everyone see that?
Yeah.
We know that this piece here is how much? 5.5. So I'm going to redraw that triangle there. Looks like this here. And I know that this height is 5.5. Is that enough for me to find the area of that triangle? No,
No,
it's,
no, I'm sorry.
it's not, because what else do I need? I need the base. Do I have it?
Yeah, it's basically gonna be 4 because the top of it says that one of the lines is 8 yards.
Do you guys see that here, this 8? So this whole thing is 8. So I'm actually going to make this a little bit easier for myself. I'm going to go ahead and use this whole triangle because I know this base is how much?
8.
And the height is 5.5. So let me redo that. So look good looking out there, Lorena. So this is 5.5. The base is 8. So 5 times 8 is 40. Half of 4 is 4. So that is 44. Yeah? And then I got to divide it by 2. I should show you guys what I'm doing here. 8 times, or so the base is 8. The height, base times height, is 5.5. And then I got to divide this by 2, don't I? Okay? So here's what happens. 2 goes into 8 4 times. 4 5s is 20. And then half of 4 is a 2. So the area of this triangle is 22. How many of those triangles are there? 5. So 5 times 22? 110? So 110 multiply by that. Boom. Sapo verde. Say yay what? Yay math. That's easy, huh? Yes, I love when you say it.
Never mind, okay.
Other questions here, guys?
Yes and no.
Yes and no?
Wait.
Any questions from anyone on this problem?
Yeah.
Kenna?
Okay.
It was just this here. Let me go ahead and redo that. So the base is 8 of this triangle, right? And then the height is 5.5. To find the area of a triangle, it's base times height divided by 2. 2 goes into 8 how many times? 4. So what's 4 times 5.5? What I did was just go 4 times the 5 by itself, which is 20. And then the 0.5 is half of 4, isn't it? Which is 2. But if you do it in your calculator, you just go straight to 22. Okay? That's where it came from. And then we multiply that by 5 because there's 1, 2, 3, 4, 5 of those triangles in there.
How do you make the connection between like the 8 and the triangle?
Because it was there, and Lorena did it. It's called practice. That really is. For that one, it is. There's other ways you could have done this. Fortunately for us, we didn't have to. But that's where I was going. I didn't notice the 8. Lorena did. So, shout out. Cuckoo! Okay? Any other questions? Oh, the king of the jungle. Any other questions on this?
Can we do another problem?
Yeah, but I want to make sure everyone's got this one.
Just,
We're going to do a bunch of them.
I want to make sure.
We're going to go to the bell. What's up?
So do we just like take like a portion of it and like?
Yeah, because there really isn't a formula for a pentagon. We have to break it down and then create it.
Okay.
That's why it's important to understand what you're working with. Kind of like when we did the trapezoid. We say, oh, that's the same thing as 2 triangles. Find the area of the base and those, all that good stuff. Okay? All right, so that was number something. Any one of these you want to see?
I wanted the triangle one that has like the.
You want the cheese?
No,
Number
the bottom,
8.
right
Number 8.
below that.
8.
8.
Oh, gee.
This one?
Yeah.
Oh, Lord?
It
Serious?
looks- Yeah.
Okay.
It looks hard.
I'm not going to try to draw this one.
Okay. I'm not going to try to draw this. Is that what you said?
Yeah.
Oh, I missed a number here. Let me. I don't want that image.
I wish I could do that with like
So now, so think about this like it was, if it was that right geometric solid, okay? I would still have to find area of the base, multiply by the height, right? Except because this is conical, then do I want the full thing? How much of it do I want? I want exactly a third of that, don't I? Okay, so there's my basic formula setup. Okay, anyone understand that? Someone not understand that? Okay, whenever we have cones like that, pyramids of any type, it's going to be just like if it was a right geometric solid, but it's only a third of it. And the easiest way to kind of explain it to you is think about it. You're looking at it like this, right? That shape inside looks like that, and you want one of what would be 3 pieces. Okay, and of course there's some in the front, but that makes up a third, and there's some in the back, which makes up the other third, and this piece would be the one inside that you're looking for. Okay, that's the one that's been the easiest and fastest way to explain to people.
Is 5.2 pointing at the dashed line?
Yeah, we're gonna need that. We're gonna need it because we're gonna do something just like we did with the previous one that Lorena pointed out. Okay, because if you take a look at the base, this is a hexagon, isn't it? Okay, so I've got a hexagon. See if I can mess this up for you guys. No more messing around. Oh, what?
It's
It's
right
next
next
to
to
the
the
floor.
hexagon.
Oh, it goes like this. Okay, cool. So that's what the base looks like. And let's see, center's probably right about here somewhere. So I'm going to try to figure out one of those triangles and then multiply it by 6. Yeah, okay. So I know that this height is how much? Yeah, so that's 5.2. Do I know the length of this? It's 6. They gave it to me, right? So base times height divided by 2. Base times height divided by 2. 2 goes into 6 3 times. 3 times 5 is 15. What's 20% of 3? 2.4? Would that be 2.4?
What was your question?
Wait, what was your?
No, it would be 0.6. 20% of 3.
0.6.
0.6, huh? So this would be 15.6. So 15.6 is the area of the base, correct? Now watch how this works. This is area, isn't it? So this is 15.6 miles squared, isn't it? So I've got 1/3, 15.6 miles squared. And what's my height? 12 miles. 3 goes into 12 4 times. 4 15s is 60. Yeah?
Yes.
And then 4 times 0.6 is 2.4. Okay, so I've got 62. Oh, that's not right at all, huh?
You took the area of one triangle.
Okay.
Don't just multiply everything by 6 now.
Oh, I didn't multiply by 6 of them. Good looking out, Lorena. Let me get rid of this. No, good. No, that's good because I missed it. Okay. This was the area of this triangle. How many triangles were there?
Okay.
Right? So this guy needs to get multiplied by 6. Someone's awake.
93.
I'm doing it. I'm not even awake. What is it?
93.6.
93.6. 93.6 miles squared. It's still 12, so 3 still goes in there. So I need 4 times 93.6. What is it?
31.2. Or are you not dividing?
We should have that number.
I was dividing 96.6 by 3.
Yeah, I got 374.
374.4?
Yeah.
There's our number right there. So 374.4, and then check this out. Miles squared times miles, what gives us miles cubed? Huh? When you're multiplying exponents, you really add them.
Okay, so it'd be like basically a squared times a squared. No, a. So whatever.
If you did a squared times a squared, that would be a to the 4th. Okay? Because you can kind of think about it like this. Let's see here. A squared times a squared this is really a times a, isn't it?
Yeah.
And then you're multiplying that by a times a again. Well, how do you write that shorthand? A to the fourth. So the shortcut is add those two.
Okay, and there's like different ones.
Oh yeah. For sure. For sure. How you guys feel about those volumes now?
I'm ready.
Not so bad, yeah?
I didn't know what
You need to see more? Here, let's do this real quick.
No, that was the semantic.
How would I find the area of this bad boy right here?
would have to
The
find
area of the square and multiply it.
So here I would kind of treat it like a right geometric solid, area of the base times the height, but then I only want a third of it because it's pyramid in form, okay? It's conical of some sort. Here, area of the base times the height. Here, a third of the area of the base times height. 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 The only ones I have to worry about dividing by 3 would be when they become pyramids of some form. You guys see that? Yeah? So any one of these kind of, oh. Spheres. Where's my cut? Here we go. Snapshot from Progressive. Who's got the formula?
4/3 pi r cubed.
4/3 pi r cubed. So, the formula is 4/3 pi r cubed. The only number I got to plug in is 10. So 4/3 pi 10 cubed.
Yeah, it'd be
That's the diameter.
Aw, thanks. So 5, that would give me 4/3 times $1.25 times pi. That doesn't divide. So this would be what, 500? What? 400 is 100, right? And then 425 is another, so it's 500. So 500 thirds pi. And your solution should be approximately 500, a little bit more. Anybody know why? Because pi is 3 something, isn't it? Okay, so that gives us a good idea. And we said it's, yep, 523.
Do we have to be exact when it comes to the spheres?
I would get in the habit of it because you guys got a Galileo. Like, if it was just us, I'm like, all right, it's a little bit more than 500, and I'd be cool with it. But I want you guys to get into that exactitude for your own benefit. Does that make sense? What's up, Marlon? What is it? What? 4/3. Oh, I had to erase my 10, so that's a 5. It's a 5 because it's radius, and what they gave us was the diameter. It was the diameter.
And then is that a 1 next to the 2, 5, like 1, 2, 5, right?
Yeah, because 5 cube is $1.25.
Above 25?
$1.25.
Oh, okay.
125. Good. Yeah, I'm looking at you, girl. That's good. You're so quiet this year. So when it's not easy, that's when you're on your phone. JK, LOL, smiley face. I just love to harass her. What else, peeps? Anything else in here kind of scary?
No, not really.
Volumes, I'm not scared of you no more. Wait till we do surface area.
Can we do surface area right now?
No. There's only so much we should be doing at a time. Before you guys be like,
But I think
I don't want to drown.
feel like you figure out all of those like.
you know what? If you want to for fun, you can go home and find all surface areas here.